Okay, good morning. Yes.
That was sick last week. I did go to class, but I wasn't at that time. But is there, like, you said you forgot to?
Yes, but I posted a video going over the material that we went.
Okay.
So that's in the Canvas. It's Zoom recordings. And so it's all right there. Yeah. Well, definitely do it. So that way you'll be ready for the test. And then if you have any questions, we can go over that too. So, okay. All right. No, Tuesday, a week from today. Yeah, a week from today. So I wanted to give you that. So that's what I was just saying is the topics that we're going to look at today are these, and there's a lot of them. So I like to spend at least a day and a half going over these because it takes practice. You just have to practice. And the more that you practice, the better you'll be at this. So these are the 7 different factoring techniques. And so what we're going to do is we've already gone over difference of 2 squares. We've already gone over number 5. So we only have to go over 6 of them. And number 7, prime, can't be factored. So that one you'll just jump right into the quadratic formula. So with factoring, what you're doing is you're looking for x-intercepts. So that is something that you have to really get in your brain and my pen go and realize that all of these techniques, what you're doing is you are looking for x-intercept. So if it's a word problem, you're looking for where does the rocket start and stop. If it's a different word problem, where does profit start and stop? Where does revenue start and stop? So those are the x-intercepts. It's where does the parabola start, at 0 sometimes it starts on the y-axis, and then where does it end? So these are all the techniques to do that. So what we're going to do is we're going to cover all the techniques, and then I'm going to show you using those techniques how to get the x-intercepts, how to solve for x. But we need to know how to factor first, and then the solving part is just a very easy step to do. Okay, so the first one we already did, greatest common factor. Greatest common factor, you look for common terms in every single type of polynomial that you're given. And the greatest common factor can be combined with any of the other ones. So you always look for greatest common factor first. You want to make sure that there's not a common factor in all the terms. Get that out of the way, and then you can combine that with one of the other techniques. So let's go to just a reminder on greatest common factor. So this is, I broke it up by section because I wanted to make sure that you guys get practice. Like if you're like, oh, I really need to work on greatest common factor, then you can go right to that section in your OneNote and just work on those kinds. Because your homework on this section is combined. It's all combined. So that's why I want to make sure that you can recognize, see it, understand what it is, which technique you're using before you get to the actual homework. All right, so greatest common factor. When you look at this, what is in common for both of these? Okay, 4 is in common because 4 can be taken, divided out of 4, and it can be divided out of 20 also. Right? So remember, what we're doing is we're doing division. And then notice the variable. So you have x squared and you have x. So the idea behind greatest common factor is you take the highest number, right, coefficient, and you take the lowest exponent. So on the variables, you look for the lowest exponent. So remember, there's a 1 there. So what you're doing, so I'm going to write you, I would not recommend doing this I'm only writing this so you can see mathematically what I'm doing. That's the only reason why I'm doing this. You should be able to do this visually, right? So 4x squared divided by 4x. So the 4's go to 1. And then, excuse me, using your exponent rules, you're subtracting. The other way you can look at this is I have 2 x's here. I'm taking 1 away. I have x left. All right. And then the same thing for the negative 20. So negative 20 divided by 4 is negative 5. And x divided by x goes away. So it's minus 5. Now, how you check it? You should never get these wrong because there's an easy way to go back through and check. 4x times x is 4x squared. 4x times negative 5 is negative 20x. So we know that this is the correct answer. Okay, so greatest common factor, you look at the numbers, the coefficients. That's the mathy term, the big number in front of the variable. You look at that, you find the biggest number that can be divided out of both of those, and then you take out the variable with the lowest exponent, okay? All right, what about this one? Look at the numbers first, so what's in common? Okay, does everyone see it? 4 goes into 8, 4 goes into 12, 4 goes into 24. Now, some people will look at that and go, oh, 12, right? Because 12 goes into itself and 12 goes into 24, but 12 won't go into 8 evenly. So remember, your value has to go evenly. It has to be an even division. So we're going to take out 4. Notice there's c squared, c, but no c here. So you can't take a c out. It has to be in every single term. Okay, so now let's do this visually. 8 divided by 4 is 2, and then the c squared follows along. 12 divided by 4 is 3, and the c comes along. And then 24 divided by 4 is 6. And then double check, 2, 3, and 6, there's not a common factor. So we know we've factored out the greatest common factor. And then to check it, and again, checking can be mental, right? 4 times 2c squared is 8c squared. 4 times negative 3c is negative 12c. And 4 times 6 is 24. So this can be a mental check. You don't have to actually write it out. All you're doing is you're double checking that your division works. So that would be the correct answer. Okay, we'll do one more. Oh, that was the same one. I duplicated it. Okay. Now it looks a little more complicated, right? But just do the exact same thing. Look at the 4, 14, negative 32. What can you take out? What's in common? 2, good. All right, now look at the variables. You have p, and p squared. So you're going to take the lowest exponent. You have q squared, q cubed, and q to the 6th. So you're going to take the lowest exponent. So that's your greatest common factor. Okay, and then you just do the division. 4 divided by 2 is 2. P divided by p cancels. Q squared divided by q squared cancels. Okay, so again, if you're a little bit shaky on that, just set it up this way and you can see 4 divided by 2 is 2. The p's go away and the q squareds go away. So all that's left is 2. Okay. And then 14 divided by 2 is 7. P divided by p cancels. Q cubed, q squared, I have 1 q left. And then 32 divided by 2 is 16. P squared divided by p is just p. Q to the 6th, q to the 2nd, I have q to the 4th left over. And notice all I'm doing is just subtracting those exponents. 2 minus 1 is 1. And 6 minus 2 is 4. So whenever you're doing division, that's the technique with exponents, is you subtract the exponents. Okay, and then a quick mental check. 2 times 2 is 4. PQ squared, good there. 2 times 7 is 14. PQ cubed is there. And then 2 times negative 16 is negative 32. P squared, Q to the 6th, I'm good to go. All right? So any questions on greatest common factor? All right, now remember, greatest common factor can be used in combination with all the other ones. Okay, now the next one that we're going to do is called factoring by grouping. So you're going to still do greatest common factor. This is just the next level of greatest common factor. How you know you're going to do factor by grouping is you will have 4 terms. Every single time, you'll always have 4 terms. That's how you know you're going to do factoring by grouping. So when you look at that, find one. Okay, don't get sick. Don't look. Look away for a minute. I don't want to make you sick. Okay, so this is an example of what it's going to look like when you do factoring by grouping. Okay, so you're going to do greatest common factor and then greatest common factor again. So when you get to this step, this is going to be your second step. You can see I have x plus 3 and x plus 3. These two binomials, which is what you'll have, will always be the same. They have to be identical for factoring by grouping to work. So then what I can do is I go, okay, if I factor out x plus 3, right? I take this one and put it here, and I take this one and put it here. What I have left is 7 minus w. So that is what's going to go in the other set of parentheses. So factoring by grouping, you will have 2 sets of parentheses, two binomials, always. Every single time you'll have 2 binomials. All right, so let's try one. Get to one here, sorry, don't look. All right, so here's your 4 terms, right? Here's 1, 2, 3, 4. That automatically tells you you're going to do factor by grouping. All right, what you're going to do is you're going to group the first 2, and then you're going to group the second 2. Okay, so the first 2, I'm looking at this, and I go, okay, what is in common just between the first 2 terms? So what can I factor out of the first 2 terms? Okay, t to the 3rd power, right? So the t's are in common. And then what's left is 5 minus 3. So I have t squared plus 2r. Everyone see it? And then again, I can check. T cubed times t squared is t to the 5th. T cubed times 2r is 2r t to the 3rd. All right. Now I'm going to bring this sign down. Always use that middle sign. And what that does is it takes care of the problem. It takes care of the sign issue that's going to happen. Okay. Now this one, I'm hesitating because these 2 are not going to be the same. This is a different, this is a greatest common factor problem. Hang on, forget it. Let's move on. Sorry, here we go. This is the one I'm looking for. All right, and it actually says it. If I had had it over here, factor by grouping, and this one was factor the GCF. So sorry. Okay, we're going to start over. All right, here we go. I'll go back and finish that one so you can see how you would know whether it's factoring by grouping or not. All right, here we go. What's in common between 15xz and 20x? An x, what about the number? 5x, good. And then I have 15 divided by 5 is 3. The x's cancel, so I have 3z. And then 20 divided by 5 is 4, and the x's cancel. Okay? Now I'm going to jump over here. I'm going to use this sign, whatever that middle sign is. And I go, okay, what is in common between 6yz and 8y? 2y, good. And what's left? 6 divided by 2 is 3. The y's cancel. I have a z. 8 divided by 2 is 4, and the y's cancel. Do you notice these are the same? Okay, since those are the same, then I can factor one more time. So greatest common factor, this is in common, and what's left goes in the other set of parentheses. Okay, so let me show you what would have happened had we continued on this one. So using that middle sign, here I factor the the t squared out, and I end up with 3t squared plus 4r squared. Do you see how this and this are not the same? They're still t squared and r squared, but they're not the same. Your two sets of parentheses have to be identical. That's how you know that it's factoring by grouping. If they are not identical, then you're going to go, okay, that didn't work. And then you're going to go back and go, all right, what can I do with this? So this one, you go, oh, there's t's included in everything. So I would take out a t squared and then just factor that out. Okay, and now you can see we don't have a t here, so we don't have anything in common here. Okay, so that's how you know. These sets of parentheses have to be identical. That's how you know whether you have factoring by grouping. All right, so we have 3z plus 4, 3z plus 4. We know we have factoring by grouping. We factor out a 3z plus 4, and what's left goes in the other set of parentheses. Okay, now you can always double check. Remember, there's always a way to double check whether you have it right. You're going to do FOIL. So remember the 3z times 5x plus 2y and 4 times 5x plus 2y. Okay, so we're going to take this and multiply it through and take the 4 and multiply it through. So we end up with 15 xz plus 6 yz plus 20x plus 8y. See it? There it is. Here's your 15xz. There's your 6yz, 20x, and 8y. And it doesn't have to be in the same order, just has to have the same signs. So we're good. So we know that it works. So doing that check, and you again, you can do the checks mentally. You don't have to write it down, but it does help it helps build your confidence because you know you were able to factor it out and then put it back together and you get the original equation. All right, here we go. Here's another factoring by grouping. So again, you're going to take the first two and then the second two. And you're just going to do GCF on each of these. That's what you're doing. So what is in common between 8xy and 12x? 4x, perfect. And what's left? We have 8 divided by 4 is 2. The x's go away. We still have a y. 12 divided by 4 is 3, and the x's go away. And then again, I'm going to use this middle sign. So this, whatever that is, I'm going to use that. And then what's in common between 10y and 15? 5, perfect. Okay, so 10 divided by 5 is 2. The y follows. And then 15 divided by 5 is plus 3. Now, let me go ahead and finish it, and then I'm gonna change it up for you so you can see. So we have 2y plus 3 is in one set of parentheses, and the 4x minus 5 is in the other set. Okay, and then mentally check. 2y, 4x is 8xy. 2y negative 5 is negative 10y. 3 times 4x, there's your 12x. And 3 times negative 5 is your negative 15. Okay, now I'm going to do this in a different color because I want you to see how important it is to bring that middle sign down. All right, so same thing. What's in common? We have 4x. And I have 2y plus 3 left. And then let's say I'm not paying attention and I bring down, I use plus, so I'm taking out a positive 5. I would end up with a negative 2y minus 5. Oh, sorry, minus 3. Do you see how this and this is not the same? Remember, those two sets of parentheses have to be identical. The reason that works bringing this negative is because I brought the negative down. So now it's negative 5 times 2y gives me negative 10y. And negative 5 times a positive 3 gives me a negative 15. So if you use this middle sign, it takes care of the sign issue. Okay? You will not end up with something like this where these are not identical. They have to be identical, same signs, same values, same variables in order for factoring by grouping to work. So we're good. Okay. All right. Any questions so far? And you're going to get lots of practice on this. So, all right, I'm going to give you a couple minutes. Go ahead and try this one. And these are not in your packet. This is something that I created for a different class. So we're not working in your packet yet. We will in a minute. That's so cute. I just saw in the back of my classroom, there's a set of encyclopedias that brings back lots and lots of memories. I would spend hours having to do research out of an encyclopedia. I'm old. It was way before, way before computers. And you actually had to go to a library and find things. You couldn't go to Google. I don't know. Everyone says, "Oh, we've come so far." You just wait. All of you guys someday are going to go, I remember when. Maybe we'll all go back to no internet, back to having to, hunt and fish. And I don't go back that far. All right. So I'm making sure I have everybody. How you feeling, Delaney? Are you in bed? Hopefully not. Okay. All right. All right, I'm gonna start doing it and you just kind of keep working. If you're still working on it, just kind of keep working. And see if you come up with the same answers that I got. Oh, I am all winky. All right, here's a little hint. When you have r minus 8, it looks like there's nothing in common, but you have to have something to connect the 8r squared to, right? You have to have something outside of your parentheses. So the one thing that is in common is a 1. So when there's nothing there visually that you can see, you can always factor out a 1. And you still get r minus 8. So now you can see these are the same. It's so winky all of a sudden. So it is r minus 8 times 8r squared plus 1. So remember, whenever you're doing these factor by grouping, you have to have 2 sets of parentheses with binomials in them. That's how you know you've done it correct. So even when there's nothing in common, there's always a 1. So you have to have something to connect your first term to. Okay? And then again, you can multiply through. R times 8r squared is 8r cubed. R times 1 is r. Negative 8 times 8r squared is negative 64r squared. And negative 8 times 1 is negative 8. So you know you did it right. And it's a quick, the check has actually saved many students from making a grave error and getting the whole thing wrong. Just by taking those few seconds to just kind of walk through the whole process of multiplying through those parentheses. Okay, everyone good? All right, let's try one more and then we'll move on to the next type. And I just figured today we're going to get as far as we can. If we don't get through all of them, we'll finish it on Thursday. And then those who are on Zoom, if you'll type your answer into chat, just so I know you're following along. So this will make you feel a little better. We have, including this week, we have 1, 2, 3, 4, 5, 6 weeks until Thanksgiving. And then 1 week after Thanksgiving, and then finals. So we really, I mean, technically we have about 6 weeks of actual new concepts to do. And Delaney, I do have a copy of the test 2 review for you. I can leave it at the front desk. They have a box for me up front in the office. If you want, I can leave it there for you, or just give it to you on Thursday, or you can print it up yourself. So whatever you want me to do. Okay, perfect. Some people have printers and some people don't. All right, here we go. So 3 and 6, we have the 3 in common. We also have an x squared in common. So what's left is y minus 2. Okay. And again, the more you do these, the faster you're going to be in recognizing how to divide things off. Okay, Nathan, let me see how you are. You already got the y minus 2, so you're good there. And then minus, and then again, what's in common is 3x. And what's left is y minus 2. Why is it a negative 2? Because negative 3x times negative 2 gives me a positive 6x. Okay, so whenever you use this middle sign, if it's a negative, it's going to take care of the positive negative issues for you because you're dividing off a negative. Okay, another way to see this, and this is just, it may be helpful. When you're dividing 3x squared from 3x squared y, do you see how the 3x squared goes away and all you have left is a y? Here, the x squared goes away and all you have left is a 2. Here, the 3x goes away and all you have left is a y. And then this one, the x goes away and all you have left is 2. So there's different ways to see this. If you need to go ahead and write the whole thing out and show the division while you're still learning it, that's 100% okay. All right, so here's one that has a little bit of a twist to it. Okay, so this right here, most people don't pick up on this right away. When I write 3x squared minus 3x, I notice that there's a 3x in common, right? So I can factor the 3x out again. I can do another greatest common factor out of here. So get a whole different color. So if I factor a 3x out of here, I end up with x minus 1. So the final answer is 3x times x minus 1 times y minus 2. This is the correct answer. Okay, now if we go back to the beginning, so remember I said that your greatest common factor is something to always look for first, right? So I can see, oh, there's a 3x in every single one of these. So if I factor out the 3x, what I have left is xy minus 2x minus y plus 2. Okay, then I can do my factoring by grouping, right? So here I have the x's in common. I have y minus 2 left, minus 1, because that's what's in common between these two, and I have y minus 2 left. So again, I end up with 3x, y minus 2, and x minus 1. So you get the exact same answer doing it either way. Most people, when they see 4 terms, they go right to the factoring by grouping, which is fine. Just notice if you have a common term in one set of parentheses, you need to factor that common term out. Okay, or if you see, oh, I have a common term, a greatest common factor, do that first, and then you can do factoring by grouping. But either way, you'll get the exact same answer. But I wanted to show you both because most people do it this way. They see 4 terms, they go right to it, and then you have to go, oh, I have a 3x in common, so I'm going to factor that out. Okay, or always look for greatest common factor first, and then you can factor by grouping. Okay. All right. And like I said, we're going to get lots of practice on this today. Let me go back to, sorry, I don't mean to make you sick. Don't look. No, that's the wrong. Oh, sorry. That's not what I wanted. Okay, this is what I want. So this is page 150, sorry, 155 in your textbook. So we're just gonna, or if your textbook, your packet, we're just gonna stop here, practice a couple of the different kinds. So this is greatest common factor and the factor by grouping method. So again, 1 through 6 is greatest common factor. So pick 2 of those. So you're going to pick 2 of these, since we've already practiced this before. And then from 7 to 12, I want you to pick 3. Okay, so from 1 to 6, pick any 2. 7 to 12, pick any 3. And I'm going to do all of them so you can check your work. So you can make sure that you're doing it correctly. And hopefully the factoring, the greatest common factor, you should be able to go fairly fast with those. So remember, it's the highest of the numbers that goes into both and the lowest exponent. So there's the first 6. I'll let you, once you're done with any 2 of those, take a look and make sure that you did it right. And you can't see this 3 very good. Threes are so hard. And then once you check the 2 that you picked, go and pick 3 from the factor by grouping. And please ask me questions if you have them. If you aren't sure how I got something. All right. And then the last two. And then again, the number 9, we just did one just like it, same exact thing. Had to factor out the 3x again. And then on number 11, you notice there's a 2 involved. So I'm going to factor out the 2 and I get 4x minus 5 and then 7x plus 3y. So if this was a test question and you left it here, you'd get marked off. There would be some points marked off. So make sure when you simplify to the very last step where you can't simplify anymore. Okay, so there's your 6 problems. You picked any 3 of them. Now, if you want, just to have more practice, go ahead and write the answers down next to it, and then go back and make sure that you can work to those answers. And the answers are in the back of the book too, the back of the packet. So you can always check there also if you don't have time to write them down. But it's just always a good idea to just do these over and over and over and over, do one kind. And you can, let me show you a website. This website is awesome and it's free. You can do math worksheet. I do math aids. And so like here, I put in the search bar factoring. And you can do factoring by grouping if that's the one that you want more help on. And it creates these worksheets. So here's factoring by grouping worksheets. So, and then you can kind of set it up. Do you want the first term to always equal 1, greater? Do you want a mixture of both? So I'll do mixture of both. And then you hit create. So this is math.aids.com. And you hit create. And it creates these worksheets. Hang on. So here's your worksheets. These are all factoring by grouping. But the best part is here is all the answers. And you can print it if you want, or you can just look at them here and then go back or scroll down and find and see that your answer is correct. Okay, so there's all kinds of practice to do. If you want to go into Khan Academy, which I'm not a huge fan of Bill Gates, but he's the one that set the Khan Academy up. He funded it. I'll put it that way. He funded it. And then you can type in the search bar and it comes up with exercises. Okay, so you can actually do them right on the right here, which we'll get to these kind. But here's factoring by grouping. Here's videos. Here's the other kinds. This is like the written out how to do it. And then let's see, where is the other? I think this is like a lesson. Okay. And then you can do the exercises and it gives you more, it walks you through the process. So Khan Academy is actually really good. Sal Khan's, S-A-L-K-H-A-N, is the man that does all the videos, and he's very good at what he does. But it's nice because you have videos, you have written out lessons, and then you have exercises that you can practice on. Okay, so that's another resource for you. The reason why I'm showing you that is because the only way to get good at factoring is to do it. You just have to do it over and over and over and over and over again. All right, so everyone good? Okay, all right, so the next technique is called factoring trinomials. I'm sorry, I'm trying to get to the top. I don't know why it does this. It always sends me to the bottom. So a trinomial just means something that has three parts to it. And this particular trinomial is when the A is 1. So remember when we're doing where we get the A, B, and C, it's in the form ax squared plus bx plus c, right? This is your standard form. So when A is 1, that's the technique that we're going to learn right now. So when you look at this, so this is your A, there's nothing there, but you know there's a 1 there. Okay, so your first step is to write 2 sets of parentheses, because you will always have 2 sets of parentheses. In the first position, you're going to have x times x, because that is the only way to get x squared, x times x. Okay, to get your negative 14, this is how I do it. Lots of other people have lots of different techniques, but the idea is you put your C at the top and your B value at the bottom. Okay, so the questions are, what are the factors? So remember, factors are, what did you multiply to get negative 14? And from those factors, you add to get negative 5. Okay, so you always start out with the factors of 14. So 1 and 14, 2 and 7. So 1 times 14 is 14, 2 times 7 is 14. Now, one of them has to be negative because you're multiplying and you're getting a negative. How do you know which one is negative? You look at the bottom, and because we're adding, remember it's the phrase, when you add unlike terms, you give it the sign of the larger number. So what that tells me is my larger number has to be negative. Okay, so then from there, when I add these two, I get 1, run out of color. I'll do it over here. I get 1 plus a negative 14, which is a negative 13, and I get 2 plus a negative 7, which I get negative 5. Well, there is what I need. Okay, so it's only one set of factors. And so my factors are a positive 2 and a minus 7. So that's how you're going to factor. You ask yourself, what are the factors of negative 14 that when I add those factors up, I get negative 5. So you multiply at the top, you add at the bottom. And it has to be one set of factors. You're not going to mix them up. It's just one set of factors. Okay. And then again, there's always a way to check. So remember either the FOIL method or the distributive property. Remember we did it this way. So x times x is x squared. X times negative 7 is negative 7x. 2 times x is 2x, and 2 times negative 7 is negative 14. So when I add these, I get x squared, negative 7x, and 2x gives me a negative 5x, and then negative 14. So this checks. So I know that this is correct. Okay, so you can actually multiply it out, or you're going to get so good at this, you're going to do it this way. So when I know I'm going to get x squared from x times x. So really the only thing that I have to double check is the outside, which was here, plus the inside, which is here. Because I know 2 times -7 is going to give me -14. The only thing I don't know for sure is the outside plus the inside has to be -5x. So the outside is 7, -7 times x is -7x. The inside is 2x. So -7 plus 2 gives me -5. So I know I've done it correctly. Okay, so factors of C that add to give you B or the middle term. All right, so let's try it again. And again, the only way you're going to get good at this is if you do them over and over and over and over again. And what it does is it gives you a number sense. It gives you a sense of, okay, I know what these numbers are. So what are the factors of 48 that when I add, I get -16? So it really forces you to really know your positives and negative rules. So the only way to get a positive 48 is a positive times a positive or a negative times a negative. If I'm adding to get a -16, a positive plus a positive gives me positive, a negative plus a negative gives me a negative. So I know my both factors are going to be negative. So I have 1 and 48. And what's nice about this is the more that you do this, the more comfortable you get with all the factors. You don't have to write every single factor. So 3 times 16, 4 times 12, 5, 6 times 8, and that's all there is. Okay, so because I'm multiplying to get a positive, but I'm adding to get a negative, that means all of these have to be negative. So do you see the factors that add to give me -16? Yep, -4 and -12. Okay, now you can go through and add these and you get -49, -26, -19, -16, and -14. So we know that it's got to be -4 and -12. So we have z times z, we have -4 and -12. Okay, so using that shortcut technique, I know z times z is going to be z squared. I know -4 times -12 does give me a positive 48. So now we're just going to double check. The outside is -12z. The inside is -4z. And when we add, we get -16z. So we know it checks. So we know that this is the correct answer. Okay. So any questions so far? People on Zoom, you feel good about it? You're going to see a lot of these. All right. So this one, if you notice, it's out of order, right? So you always want to rewrite it so it is in descending order. So the squared term comes first, the single variable comes second, and then the constant is third. So now I have A, B, and C all in the right order. Okay, give you a couple minutes to think about it. Factors of -6 that when I add, I get -5. And be careful of the signs. So if it's factors multiplied, one has to be negative, one has to be positive. Okay, so factors of -6, 1 and 6, 2 and 3. One of them has to be negative. I look down here and I go, okay, my bigger number has to be negative. And then when you add them, 1 plus a -6 is -5. 2 plus a -3 is -1. So I know that my factors are 1 and -6. So 2 sets of parentheses, W times W gives me W squared plus 1 minus 6. Now, it does not matter what order. I could have written it as W minus 6, W plus 1. That's okay. Switching the entire binomials is fine, but the signs have to be in that order. Okay, and then to double check, I know W times W, W squared. I know 1 times -6 gives me -6. So the outside is -6W. The inside is a positive 1W, so I get a -5W. So I know that this is the correct answer. Outside plus the inside. Okay. All right. So now let's jump to page 156 in your book. And I'm going to give you some to. So this is page 156. Okay, so 13, 14, 15, 16, 17, and 18 are all, if you notice, they all have a 1 in front of your x squared. So on these, I want you to pick 4. So any 4 from 13 to 18. And anyone on Zoom, if you have questions or you're not sure, what the thought process is, let me know. Either unmute yourself or you can put it in chat. So since your homework, this last homework is not due until Friday, the 25th, what I would suggest is to, on the homework, go through, because we're not going to get through all the techniques today. I'm going to save the last one for Thursday. But go through your homework and just identify the problems that we know how to do. Greatest common factor, factoring by grouping, the trinomial where A is 1. Do all the ones that you can. And then on Thursday, you'll only have a handful of problems to do that's due Friday. And I think you have a quiz due. So quiz due. Oh, that was due last month. Quiz 8. If you did 13 or 14, there's the answers for those. Whew. There's 14 or 15 and 16, if you pick those. And hopefully you'll get to the point where these are very quick. You see the numbers, you see what the factors need to be, and you can see what the sum of those factors fairly quickly. But again, it just takes time. It just takes practice. You have to put in the time to be able to get really good at these. And there's 17 and 18. Okay, so one thing that is a little bit different on number 15 and 17, but the concept is the same. So because you're getting on 15, you're getting a negative 28 when you multiply. You know, one has to be positive and one has to be negative. Well, this bottom, the middle term indicates which number is going to be positive, which is going to be negative. So if the bottom term is positive, your larger values all have to be positive, as opposed to like 13. Oh no, I'm sorry, 14, your larger number had to be negative because when you add, you get a negative 14. Okay, so those are those little nuances of positive and negative numbers that will force you to really know, okay, when I add two values, I'm going to give it the sign of the larger number. So on 14, your larger number would be negative. On 15 and 17, your larger number would be positive because you have a positive middle term. Okay? All right, any questions on those? Zoom, you guys are good? Okay, thank you, Nathan. Okay, so what I'm going to do is I'm going to skip the factoring a trinomial where a is not 1. So this is what it looks like, right? Your first term, let me get to one. Your first term, the a term is a value. Okay, so we're going to skip that for now because that's the one that takes the most brain power. What I want to do is I want to get to our two special factoring ones. This one you already know. We already did this one. Difference of two perfect squares. So I'm going to save the other trinomial for Thursday. So remember, with difference of two perfect squares, we talked about this last week. You have a binomial, right? Two, both of them are perfect squares. How do you know? Well, the exponent has to be even, and the value has to be a perfect square. So remember, perfect squares, and this is going to come into play in the other one, the perfect square trinomial. Perfect squares are 1, 4, 9, 16, 25, 36, 49. So in my head, what I'm doing is 5 times 5, 6 times 6, 7 times 7, 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. And then we have 121. 11 times 11, 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196, and 15 times 15 is 225. These are the top 15 perfect squares. These are the ones you'll see the most. So that's just something to make sure you recognize a perfect square. So when you have a perfect square, we're going back this way, right? When you multiply, you know you're going to have two sets of parentheses. You know x squared is going to be x times x. And you know 25 is going to be 5 times 5. The only thing you have to remember is one is plus and one is minus. And the reason for that is notice you don't have a middle term, right? You just have two perfect squares with a minus sign in between. So to check that, you're going to do the outside plus the inside again. So the outside is negative 5x. The inside is positive 5x. Those cancel to 0. That's why there's nothing there. Okay, so binomial, you're going to have two sets of binomials. One's plus, one's minus. Okay, so this one, you have x times x, 1 times 1, plus, minus, or minus plus. It doesn't matter which order you put the plus and minus in. Okay. All right, try the next 4. Go quick. These are just ones that I'm giving you. So you just put them in your notes or on the side. And then we'll jump to page 158. Actually, I think we already did 158 in our book. That might be something you missed. So just basically all you're doing is you're square rooting each term, and then one's plus, one's minus, and that's it. Okay. Now, 5 and 6, there's a little bit of a little wrench into the system because we have x. No, that should be x, not a. Because we have x to the 4th. All I'm doing is I'm cutting that exponent in half. So that's why you have to have an even exponent for it to be a perfect square. You just cut it in half. But this x squared plus 1, we can't do anything with. But the x squared minus 1, that's another difference of two squares. So sometimes you have to do it a second time. So x squared is x and x, 1 is 1 and 1, 1's plus, 1's minus. So on number 5, you end up with 3 binomials. Excuse me. You can't do anything with that x squared plus 1 because there's no way to factor that. You can only factor again the x squared minus 1. So if there's a minus sign in it and you have two perfect squares, you can factor it again. Okay. And then number 6, exact same thing. Now, even though it's a fraction, 1 over 81, just remember you can square root each piece. So the square root of 1 is 1. Square root of 81 is 9. Okay. And then I have difference of two squares again on the x squared minus 1/9, because the square root of 1 is 1, square root of 9 is 3. So it's going to be x and x, 1/3 and 1/3. 1's plus and 1 is minus. So again, you have three terms. So don't think that you stop just when you factor one time. Sometimes you have to factor again. So you have to always be aware of that you might be factoring it again. Okay. All right, so I'm going to scroll back up because I want to do, this will be the last one. I want to do the factoring, the perfect square trinomial. Okay, so a perfect square trinomial means there's 3 parts. What we're going to do is we're going to take this perfect square trinomial and we're going to take it back to the factors. So what did you multiply together to get the perfect square trinomial? How do you know that it's a perfect square trinomial? The first term is a perfect square and the last term is a perfect square. Okay, that's the first thing you look for. First term is a perfect square and last term is a perfect square. Then the middle term is when you square root a and b and you double it. So here's why. So let's say I have x plus 4 times x plus 4. Okay, so this is our 2 binomials. We're multiplying them together. So I'm going to do x times x plus 4 and then 4 times x plus 4. So I get x squared plus 4x, and then I get 4x plus 16. Okay, so when I add these together, do you see I have 2 of these? Right? So I end up with 8x plus 16. Well, when I look at this and I'm taking it back to the factors, this is a perfect square because my exponent is even. This is a perfect square. When I take the square root of each of those, multiply, and then double it. So if I multiply 4 and x, I get 4x. If I double it, I get 8x. That makes it a perfect square trinomial. Okay, and the reason why I double it is because I end up with 2 of them. 2 of the outside and the inside. Okay, so remember this and this is the same thing. X plus 4 times x plus 4 is the same as x plus 4 squared. Okay, so what's nice about this is you can get some pretty complicated trinomials, right? If I showed you how to do this using the other technique that we're going to learn on Thursday, it would kind of boggle your mind because you have to get factors of 4, which is 1 and 4, 2 and 2, factors of 25, 1 and 25. There's a lot going on. But if you notice right off the bat, oh, that's a perfect square, and that's a perfect square. Once you notice that, take the square root of each one, right? So square root of 4 is 2, x squared, square root is x. I just cut that number in half. Okay, now watch. If I multiply these two, so 2x times 5, I get 10x. If I double this, you see how I get the 20x? This means that that is a perfect square trinomial. So I'm going to use this first sign. So it's 2x plus 5 squared, or you can write it as 2x plus 5 times 2x plus 5. And again, if you don't trust yourself, you can always check it. 2x times 2x is 4x squared. 2x times 5 is 10x. 5 times 2x is 10x. There's my 20x. And then 5 times 5 is 25. Okay, so the difference of two squares and the perfect square trinomial, it's a visual. You have to be able to recognize it right off the bat. Okay, so on number 2, perfect square, my exponent is even. 1 is a perfect square. People forget that. People forget that 1 is a perfect square all the time. So I'm going to use my test. Square root of x squared is x. Square root of 1 is 1. If I multiply those and double it, I get 2x. So I'm good. So I'm going to use this first sign and square it. So you can write it either way. Either way works. I like the first way because you're done. X minus 1 squared. Okay, any questions so far? Once that concept of perfect square trinomial hits you, you go, oh, this is so much easier. All right, so here we go. Perfect square, 6x. Square root of 25 is 5. 6 times 5 is 30. Doubled gives me 60. I know I am good. All right. All right. 81 is perfect square. 100 is a perfect square. So I have 9x and 10. 9 times 10 is 90. Doubled is 180. I am good. And again, use that first sign. That's how you know which sign to use. Anyone want to give me number 5? 7x and 2. 7 times 2 is 14. Doubled gives me 28. I'm good to go. Okay, so don't let fractions scare you. Remember, 1/25 is the same as 1/5. 36 is 6. So if I'm doing my math correctly, I get 6 over 5. Doubled gives me 12 over 5. There's my middle term. So it's 1/5 x minus 6 squared, and I'm done. Nice, huh? I love that trick. It's my favorite one. All right, so let's practice a couple, and then we will be done for the day. I'm sure your brains are probably exploding. It's a lot of factoring. Usually when you first learn factoring, oh, you know what? They don't give me these. I don't like that. Okay, I'm going to give you a couple to practice. Just to seal the deal. All right, try those two. Okay, so when you're doing these, again, it's easy to just square root the first and the last, but always just take a second to double check, because I have seen them where when you do this technique and the middle term doesn't turn out right, that it can throw you. So I always double check. So I have -35 squared, or I'm sorry, not squared, -35 doubled does give me -70. And then 11 times 10 is 110, doubled gives me 220. So I know I'm good with both of those. So you always want to double check that that middle term completes the perfect square trinomial. Okay. All right. Any questions? So I'm sorry. Any questions? We might have time to start it. Yeah, so I would do the review on your own, and then if you have any questions, then we can go over the review. Okay. All right. If that's it, I'm gonna let your brain rest a little bit. Practice, practice, practice. Do whatever you need to do to make sure that you have these concepts down pat. And then I will see you on Thursday.